Hello everyone, myself Prabhashri, Department of Mathematics, Assistant Professor, SNS College of Technology. In this video, we are going to see a case study video about matrices and calculus and application oriented in topics related with eigenvalues and eigenvectors and application.
And the movement of the robots.
Next one.
Computer simulation, matrix represents relation between multiple variables in physics and simulation such as motion force.
Solving linear equation systems AX equal to I can be solved easily using matrix methods. Used to perform
Say it loudly now.
in image and 3D models.
Matrix store gets neural network maintained. They help complex computer form complex calculation, effective during the learning and prediction.
Matrices are used to encode and decode messages for secular communication.
To represent data from perform static analysis and solve different equations.
Next.
To encode and decode messages for secure communications.
Matrix helping coordinate transformation to find accurate position on it.
One of the applications of matrix is crash simulation and safety analysis. In crash testing, matrices represent forces, stress, and deformation of car structures.
The another application is vehicle motion and dynamics. Matrices are used to analyze control and vehicle motion such as acceleration, steering, and braking.
Another application is computer-aided design. Automobile designers use matrix to rotate, scale, and transform 3D models of car components. Used to represent and solve differentiation ones.
Matrices are used to perform operation.
Matrix used to represent and analyze connection between systems. Eigenvalues and eigenvectors important analysis by the quantum mechanics.
Robotics used to represent represent of the position and movement of robotics.
Computer graphics used in performing transformations like rotation, scaling, and translation of images.
Matrices are used in navigation systems for finding position, direction, and distance in 2D and 3D spaces. Matrices are used in navigation systems for finding position, direction, and distance in 2D and 3D spaces.
Matrices are used in encrypt and decrypt in electrical circuits, mechanical system.
Used to solve system of linear equation in electrical circuits, mechanical systems. Matrix represent input and output model to represent input and output model to study relationship between industries.
Friends, myself Manashri, I'm from ITA. I'm going to tell about the application of matrices.
Myself SJST from ITA.
So, the application of matrices include computer graphics, 3D graphics and animation. Matrices transform objects in computer games and simulations. Example, rendering 3D objects in video games or movies.
Mechanical vibration and stability analysis. In mechanical and civil engineering, eigenvalue represent the natural frequencies of vibration and eigenvector shows the mode shapes.
And in engineering, electrical networks, matrices represents currents and voltages in circuits. Structural analysis used to model and solve forces on beams, trusses and bridges. Control systems, matrices describe system dynamics.
In principle, it uses in principal component analysis in data science. PCA uses eigenvalues and eigenvectors of the covariance matrix to reduce data dimensions. The largest eigenvalues correspond to directions with the most variance.
In computer science graph theory, adjacency matrices represent connections in networks. Cryptography, matrices are used for encryption and decryption algorithms.
It uses in Google's PageRank algorithm, Google rank pages uses eigenvectors. The dominant eigenvector of a page link matrix represent its importance of ranking on the internet.
Economics and business input-output models. Economists use matrices to show how industries depend on each other. Optimization problems. Matrices algebra helps in resource allocation and production planning.
It also uses in network analysis, image processing and computer vision, differential equation and dynamic systems.
Robot